Hello, good evening, good morning, wherever you're watching this. Pretty sure no one is, but still, the stream should be live now. Hello, good
Hopefully.
evening, good morning, wherever you're watching this. Pretty sure no one is. Okay, so now we can actually get started. We left off with this. The last time you might have realized. And off camera, I made a few changes in the footprint. Basically, I had to assign footprints to some parts here. The diodes were already assigned, but the rotatory encoder was still pending. So I attached one to it. One second, not this one. So it has been assigned, I'm pretty sure. Yes, I assigned that. And I opened the PCB editor and it looked quite scary. So I decided to stop with that and make a few small changes in my schematic. So first thing which you will be doing today is adding a few RGB lights because like what is a macro pad without RGB lights anyway? So I did look up some RGB lights online and I decided that I'll be going using this. So one sec, let's look it up. I decided about this, the WS2812B light ones. So it has 4 pins. It's kind of like a series, so we don't need like multiple connections. So this is the wrong one. Yes. So now it has 4 connections, a VSS, VDD, input and output. So we'll be connecting that in a kind of a series, that is. And yeah, it's gonna be quite simple here. It's gonna be connected like this, and then again. Okay, let's add another one. I'm pretty sure I'll be going with 9 because we can have one below each switch and that will be more than good enough for me. This is the first one, so I don't really mind. That's the sixth one. 6 here, 7, 8, and that will be 9. We're done with that, and basically we have to add the ground and VCC. So we have a 3.3 volt coming out. We'll remove remove this. No use for now because we are actually going to be using it. Um, yes. So 3.3 volts is coming out from here. Is it connected? Yes, it is. Uh, One sec. Hmm, looks like just a second. So VDD. I forgot what VDD and VSS was like. One was for ground and one was for the power supply. But okay, let's search it up. This is the stuff which you have to go through when you're learning hardware for the first time, and I feel like it's quite a good thing actually. You learn stuff along the way. It's positive, power supply, MOS and CMOS circuits, okay. VSS, all level. So basically, VSS goes to the ground, I'm pretty sure. So we will be going back to archive. I will save this just in case something bad happens. So now zooming in. Let's draw a wired system first. Draw a wired straight. Actually, no, that's a bad idea. Just keep it a bit organized here. That will do the trick. That was very bad. So we'll have to redo it again. Just a straight line, don't mess up. Oh man. No. How much longer? Almost done. Yes. Not have to do that part. So we'll just connect everything here. Now we have a rail for all of them. Let's make another rail here that is be quite simple, I suppose. The one because we need like only one GNT pin, right? Nope, that was not what I was trying to do. Please. Please don't do this. Yes. Looks like it's still here and then it will go here. That's it. Now just connect the rest of it here. That's getting connected. All of them are getting connected. So now just give me a second. Yes, so we'll continue from here. That's nice. We have the railings set. We have 3.3 volt here. That's good. Coming back to our normal setup, we need a ground. Ground will be coming here, and all of it is just one wire segment. So let's not worry a lot about that. Hopefully it's gonna be correct. I hope so. Let's save that and let's run the ERC. Fingers crossed, nothing should be going wrong. I hope. Oh yeah, I forgot. We'll just add a cross sign here. I think, yeah, where's the like not used? Yes, this here most probably, and we will draw a wire, a very long one this time. Uh, this will go here. It, you're drawing a whole lasso around it again, but I don't really mind. Let's use pin 20, shall we? Forgot to remove this one, but it's okay. It's connected, I believe. So, ERC, you better not disappoint me. Looks like I got 24 errors. Oh yeah, the connections, I completely forgot about those. Forgive me. So, we will just remove these, run ERC. The warning signs won't go away, so I'll just have to deal with them. Do we have a viewer yet? Is anyone here? I don't really mind, but yes, keep it like that. One here, one here, one here. Pretty sure that's all the errors we had, right? I don't see anything else. Save this and run the ERC again. Zero errors, zero warnings. That's great to see. And let's check if we assign footprints for everything. So don't really need, that was a misclick. Let's see if we have footprints attached. Yeah, we did not really add anything else. So hopefully we switch to PCB editor now. Wait, so I have a question here. I made a change to my schematic in KiCad, but the PCB editor looks the same. What's the problem? Get it? So KiCad. Uh, I have to click on schematic editor are not automatically propagated to the PCB editor. You must explicitly run tools update PCB from schematic. Okay, so let's go to tools and let's update PCB. Getting two warnings here. Just place these here for now. That looks quite scary, but I think I'll take that. So let's take a minute of break to celebrate our schematic victory. Please, for now, that's all that we have. We have our RGBs, we have the 9 switches, we have a rotatory encoder. What else do we need? Rotary encoder. I always read that as rotatory encoder. But yeah, uh, let me. Yes. No, one sec, guys. One sec. Yes, so we are done with this. Let me just take a picture of this with my camera real quick. More iris. Yes, we are done with that. Let's also take a picture of this. Which I must admit, this is my first time in the PCB editor, so you guys must not judge me. Iris. So I'm back. So we'll save the changes here, and also we'll save the changes here. Now, for actually like bringing the PCB into shape, uh, yeah, I don't really know what's the next step. That's the main problem here. But let's hopefully, yes, bring it back to place. That was scary. Hmm. So uh, we'll close the schematic editor for now. Please close. Yes. Oh wait, I'm lagging. That's bad. Oh no. Yes, so that's good. PCB editor. Phew, I got scared for a second. Now we have a cluster of my diodes. We have 9 diodes to deal with. We have 9 RGB events to deal with. We have the rotary encoder. We have our Raspberry Pi Pico. And we have 9 Cherry MX switch holders. And I don't know what to do with absolutely any of them. So we'll just adjust this first. Never mind, that's not getting adjusted. Mm, okay, so actually I came to another decision. This is like most probably okay for me, but I did want to make a slight change. The 3.3 volt here, I realized this is yeah, that symbol I placed it wrong. I have to admit that, so that's my bad. But rest of it, it looks quite okay to me. Uh, okay. Hmm. Let's have a check again, just in case someone has to oppose me. Post it in Slack. Hardware. Schematic for macro pad which I am making in okay, so I send the message there. Hopefully someone responds in time because this is my first proper schematic. Hmm. One sec. So now the main thing which we have to do is actually structure this out well, and then we'll look at the wiring later. The wiring is like a maze. So I'll be back in a second. Sorry guys, I'm back. So I was thinking about a design for this. We'll put all these away for now. Might look scary, but yeah, I can't say it, but it's actually scary. I might actually get the help of someone here because mm, I will be reading some documents, like for the PCP design at least. Okay, that's a very simple one. They're also using Cherry MX switches. PCB design. CA21. This is quite a big key switch matrix. I have to agree. Wow. So the LED matrix looks like they're using the same one as we are. So put a separate ground for everything. Wow, that's something impressive, I have to say. Front and back. Okay. Okay. Basically, they have the switch holder. Hmm. And below that, they have the RGB lights. Looks like they have the diodes on the back, which is good. We could potentially use this as an advantage, and like we have a 3x3 layout, so it's not gonna be as big as this. Oh, this is a 4x5. That's a lot of switches. It's 20 switches, and instead we could put a rotating in here. So, hmm, that's nice. Did we get a reply yet? So we are collecting active recommendations from the hardware channel. That's also good. And yes, so what we have got for now, we're gonna copy it. No, 3, 4, 5, 6, 7, 8, and 9. All these 9 switches are going here. We'll keep them down for now. You go up, you go up. It's just a demo for now. Um, you come here, and then this will go here. Thinking about keeping the actual pipe echo here. Now it's actually quite big in size, I have to admit. And the rotatory encoder, we can keep it somewhere like here. Yeah, okay. Keep these away for now. It's quite hard getting the PCB into structure, man. I realize the pain of actual engineers now. So keep these switches in the middle. That's the main part we have to focus on. And we'll keep this somewhere like here, probably. That will be good. Hmm. These can't actually stick on each other, so we're moving them out. Hmm. Hmm. Looks fair to me. It is, right? Yes, it is. And the last blow. Uh, Hopefully it is correct. Don't want to mess with it longer. Yes. That's something beautiful, I have to say. And actually, I think we will have to be putting these somewhere inside here. Wow. No, not this. Can you come here? Yes. And put it here. And put it here somewhere. No. Okay. So now that we are done with this, we will, hmm, it's a bit closer. Now here comes a rotator encoder. This will be the fun part. I take that back. This is not fun at all. I hope for a better shape or something, but I don't feel like I'll be getting that. And I do want the Pico to be in display because that just seems cool. Because especially if it's something which you made by yourself. So yeah, I'll select all of them. And sorry, bring them a bit here. We'll be putting the diodes in the back later. So actually, let's have a look at some of the other PCBs as well, because this guy made something similar, and his looks way better than mine. I must admit that. Has an OLED panel as well, which I really wanted. I'll be back in a second. I've decided to actually add a OLED panel as well, because thinking about it, not just like taking an inspiration, it would be quite odd if there was a Pico here and there would be like, no OLED panel or anything like that. This will be a clear space, and I can't just rotate the Pico like this and put it something like here, right? So it will probably be better for me to. One thing which I could do is I can distance these switches a bit more, and then I would make some space for the Pico to actually, rest, because there'll be a USB cable here. I want that to be hidden. So for now, I would probably be more focused on adding a compensation. That is, I do not mean to make any connection. Yes, that's back to normal. And we will be saving this, but we will be adding a OLED panel here. So I will be back. So looking for OLED panels. Let's look for some OLED panels right now. Is anyone here? No one is watching. That's great. Um, um, what OLED? So 0.96-inch OLED is what it's telling me. Um, that looks cute, and that's very much overpriced. So we are not going to be using that at all. Oh, another problem which pops up here. If we use the RGB, it will be consuming 3.3 volts. But for our OLED display, we will be needing another 5 volts, I think. That's bad. That's actually bad. So I'll have to like get some more power from outside. Uh, the OLED display like this one is quite good enough. 0.96-inch, 6-inch OLED display, KiCad, schematic. So SSD 1306. Oh, it's we have to download the library again, so that's bad. Let me check for a second. Um, SSD 1306, SSD 1306. What's this? Oh wow, so they actually do have a display 0.91 inch, 128 into 32, but that's extremely bad, so we'll be looking for a better one. Uh, well, that's actually quite good, but this thing, this looks quite different. It's just a VCC ground, it's here an STA. That's not a problem, but like, why does the structure look way different here? I guess I'll just have to download a custom thing. Yeah, this one. Uh, where's KiCad here? Yes. See KiCad, that's good. That's a good sign. This is bad. I guess I'll have to just your word. No. KiCad. Seriously. So I'll have to go and confirm my email. Verify. I'm doing it on my phone, so you guys don't have to see it. It's a waste of 2 minutes, I have to admit. So now, hopefully it's verified. KiCad. Version section later. KiCad. Version 6 later. Yes. Actually, not this. Oh yes, this display. Yeah, I'm familiar with this one, so this will be perfect. Can't I download this? I will download this. I'll go to my phone. Downloads, extract all, extract. Yes. It's like I'll have to learn how to import libraries into KiCad again. I'm not a robot, please. This is not the right time. I'm streaming. It's like you're already 40 minutes into the stream. Hit of schematic libraries into KiCad. Just go to the download. That's it. Okay. Preferences, component libraries. Didn't get a reply. So the schematic looks pretty solid overall. The matrix diodes and rotary encoder wiring are all spot on. That's one major thing you definitely need to fix before. Right now you're using those WS2 LED hooked up to 3.3 line. If you turn them on, you will draw way too much current and likely fry the because overall voltage regulator. Plus, those LEDs really want 5 volts to run properly anyway. You should swap that power net over to VBus pin. Okay. So it pulls 5 volts straight from the USB. Also, you should really add a small 100 NF capacitor to the power pins of each LED so they don't flicker on you. Oh, and throwing a simple push button between the run pin and the ground is a massive lifesaver. Makes resetting the board for new firmware way easier without having to unplug constantly. This guy is really a lifesaver, I have to say. I wow. Wow, this guy. I'm gonna be talking to him later, but yeah, we'll be taking this recommendation and we'll be working on it later. But for now, we will add this library. So let's go to preferences. Yes, libraries, add library, import downloads. Why does it not show anything? Please work. Just this. Okay, okay, okay. Nope. Okay, okay. Nope. So why does it not work? Should be working quite well. Conda place component. No. Is there a way to just get this .lib file? Um, Cause I only see one .lib file. Uh, Asli, Asli ro, Asli. Hmm? Hmm. Those. So non-kai cat schematic. But for now, I think that adding the like OLED display will not be my first choice. I'll first probably be working on the like whatever advice this guy gave me. So I'll actually be learning from this guy. He looks like a guy to be in touch with. Thank you guys. I'll be back after dinner probably or by tomorrow because I do have to make at least 15 more minutes before I make my entry for today. So hopefully within tonight I'll be adding the whole display library and like stuff like that. So we'll discard the changes here.